All right, you guys, welcome back. Okay, so now we're going to be doing the same idea, except now the information is going to be nested inside a word problem or a situation. Okay, so we've got the population of rabbits on an island is growing exponentially. In the year 1995, the population of rabbits was 1,000, and by 1999, the population had grown to 1,800. Predict the population of rabbits in the year 2003 to the nearest whole number. Okay, so X is going to be our year. So in 1995, okay, we had 1,000 rabbits. Okay, in 1999, we had 1,800 rabbits. Okay, now we're going to hit zoom fit. So there's our 2 points. Okay, now we're going to write the equation. So y1, okay, ab to the x 1. Okay, all right, now just leave that information here. Okay, and now we need to predict the population of rabbits in 2003. Okay, so remember I was typing in x equals, but how do I know if it's x or if it's y? Well, look at your table. So for x1, we were typing in the years. So that means I need to write x equals 2003. Okay, now if I look down here, I can't see it because my picture only goes up to 2000. So I'm going to zoom out, okay, until I can see where they intersect, okay, and to the nearest whole number, okay, is 3,240 rabbits. There we go. Okay, and then yes, here again is all the work, okay, but we are utilizing, okay, we're utilizing Desmos to help us out. All right, so let's try another one. Okay, a sample of radioactive isotope had an initial mass of 490 milligrams in the year 1995 and decays exponentially over time. A measurement in the year 1998 found that the sample's mass had decayed to 240 milligrams. What would be the expected mass of the sample in the year 2005 to the nearest whole number? All right, so in 1995, okay, we don't have to change 1995, but we had a mass of 490 milligrams. All right, in 1998, make sure I type that in right. Okay, we were at 240 milligrams. All right, let's write that equation. Now, I keep typing it over and over again because I want you to see that you'll memorize your equations or your formulas the more that you type them in and the more that you work with them. Okay, all right, so now I need to predict, or what do I think the expected mass of the sample is in 2005. All right, so x equals, okay, 2005. Okay, all right, and it says right here that in 2005, okay, it's going to be approximately 45.385 milligrams. Well, it says round to the nearest whole number, so that would be 45. Submit my answer, and there we go. Okay, all right. I don't want to do another isotope. There we go. Okay, so I'm going to leave this one up, okay, and let's just change out our table. Okay, and you can see Desmos is giving a warning, but that's okay. It says Evan purchased a new car in 1993 for $34,200. The value of the car has been depreciating exponentially at a constant rate. If the value of the car was $19,200 in the year 1995, then what would be the predicted value of the car in 1998 to the nearest dollar? Okay, so 1993, 34,200, and then in 1995, it was now 19,200. Okay, and I'm going to hit zoom fit. So there's my 2 points. Okay, and what do I think the car will be in 1998? All right, I need to zoom out. Okay, so there's 1998, and that also makes sense in terms of I really haven't discussed about the logic of my answer. I would anticipate that the car's value would continue to go down. So if I got a value that went up, I may have made a mistake when I typed something in. All right, so now looking at 1998, looks like my car is going to be valued at about 8,076 because rounding tells me to the nearest dollar to round this way. All right, submit my answer. Yes. Okay. All right, so now let's go back, okay, and let's look at exponential regressions level 1. Okay. All right, because this one's going to be really similar as well. Okay. So it says, okay, the accompanying table shows the value of a car over time that was purchased for $12,500, where X is years and Y is the value of the car in dollars. Write an exponential regression equation for this set of data, rounding all coefficients to the nearest thousandth. So that's 3 decimal places. Using this equation, determine the value of the car to the nearest cent after 9 years. Okay, so I'm not doing anything different, okay? They've just given me a bunch of points to type in, okay? And we're going to type all of them in, okay? The more points we type in, the more accurate the equation is. Okay, so 0, 12,500, 1, 11,239. Okay, I'm going to come back and get the other variable. 8911, 8362, 6443, 5425, and 4752. So 2, 3, oops, 2, 3, 4, 5, 6. Okay. All right, let's draw in the equation. So y1, ab to the x1. Okay. All right, so now it says to write the equation. Okay. So y equals, and it says to round to the nearest thousandths. Oh, hang on. Let me zoom back on this one. There we go. Okay, so now you can see, okay, see how all these dots, they're not exact. That's okay, okay, because this regression equation is trying to hit as many dots as it can, okay, because we're using it to make a prediction, and it's because the value's not going down at a constant rate. It's just going down, okay, but the rate between 2 points is not exactly the same. Okay. So y equals, so we have 12,763.5 parentheses 0.8491 parentheses exponent x. Okay, so there's my equation. I've rounded things inside to the thousandths, okay, which is 3 decimal places. So let me take out that 1. Okay, and now I need to make a prediction. Okay, so now I need to know, using this equation, determine the value of the car to the nearest cent after 9 years. So x equals 9. All right, and let's zoom out. Okay, all right, so now this is the prediction. Okay, I don't know if that's actually going to be the value of the car, but that's my predicted value. Okay, so $2,928 is said to the nearest cent, so 23 cents. Submit my answer. Yes. Okay. Now let's talk about, okay, Desmos and Delta Math. Okay. All right. Let me hit pause. Okay, so let's talk about Desmos and Delta Math. So you can see here that my values are a little bit off, okay? So you're going to go over here and you're click on log mode, okay? All right, and I wanted you to see this, okay? And I forgot for a momentarily there. Sorry, I got distracted, okay? But when I press log mode, look at my parameters. See how it says 12863, 12863, okay? Now I get that it says 0.165 and our calculator says 2. okay, and 0.846 there it is. Okay, so we've got to be in log mode. Okay, and then if we go to x equals 9, okay, and we hit our intersection, we get 2,855.567. Okay, we've got 49 here. Okay, here's what I need you to understand about these 5 problems. Okay, if your answer is close, okay, and I mean close, like this is close, okay, when I'm looking at Delta Math, when I'm looking at here, even if your solution is wrong, I don't want you to redo the problem, okay? We're dealing with a calculator limitation, okay? Right here it says parameters might not be exact, okay? So that's what they're talking about. See how the parameter here says 12863.2. And ours right here said 12863.165. That creates a difference in calculations, okay? But the steps are the same, okay? And your EOC is not going to give you a problem, okay, that this part hasn't been accounted for because we use Desmos on our EOC. Delta Math doesn't use Desmos, okay? And that's not a problem, okay? So just realize it's okay if yours are a little bit different, okay? But you want to be close as possible to the answer that was provided. So even if you get an X, okay, just go down to the bottom and compare your answer. And if your answer is almost exactly the same, but we've got some rounding issues, you are correct. You move on, okay? Because I can actually see your individual problems on Delta Math, and I can actually see exactly what you typed in, okay? Now, if it's way off, way off, you got to retype it in. You got to try it again, okay? This is just part of, I want you to get the steps of typing everything in correctly, okay? All right, I'm going to cut the video here. Okay, if you've got any questions, let me know, and good luck.